Alright, in this video we are going to talk about Module 3. So we're going to be looking at graphs and interpreting graphs and various types of functions. So these are some of the graphs that we are going to be looking at. All of them are listed here. We have the straight line, the squaring functions, cubing functions, the square root function, cube root function, absolute function, and then the greatest integer function. So these are all of them listed, the ones that we will look at. We will draw them out. Something that you need to know, it says that a function is continuous over an interval of its domain if its hand-drawn graph over that interval can be sketched without lifting the pencil from the paper. All right, let's look at this example. So this example, we have a line drawn on our graph and it has a circle that is open. So what that means is that this line is continuous besides this one point. So that means that it is not continuous. Where x equals 3, there is no line. So if we were to look at our domain and our range, our domain would be negative infinity to 3 and then 3 to infinity. We have our range, and then we have when it is increasing. So there are a couple of examples. We go through each of these functions that we looked at. So this was the straight line function. This is the second degree parabola, so we've got our squaring functions. Below that we have our cubing function. And it just tells us if it's continuous or not, gives the domain and range when this graph is increasing or decreasing. So look at these. This is our square root function, the cube root function, and it shows you the graph. The absolute value function, and then the greatest integer function. For 3.2, it says that we are going to determine whether a function is even, odd, or neither. So it says that a function is even if f of negative x equals f of x for all x in the domain of f. It will be symmetric with respects of the y-axis. So it will be symmetric with respects of the y-axis. If by replacing x with negative x results in an equivalent equation, it is symmetric with respect to the y-axis. So we're looking at our y-axis. That is our vertical line on our graph. So there are some examples of some equations that are symmetric. Down here. And all you're doing is replacing negative x with x, and if it's the same y value, then they are symmetric. Okay. A function is odd if f of negative x equals negative fx for all x in the domain of f. It will be symmetric with respects of the origin. If replacing x with negative x and y with negative y creates equivalent equation, then it is symmetric with respects to the origin. So that is very important. We are looking at the origin. So this is it rewritten, f of x plus f of negative x equals 0. So here's an example. We've got the point 2, 2, and then negative 2, negative 2. So that has symmetry with our origin. Same thing right here. If the graph is symmetric with respect to the origin, then you should be able to replace x with negative x and y with negative y and have the same equation. This is an example of neither. It says that there is a second degree term and a first degree term. The graph is symmetric with the line x equals 1. So it does not go about the y-axis, but instead it's on this line for x equals 1. This one is the graph of an equation is symmetric with respect to the x-axis. It says if you can replace y with negative y, and it results in an equivalent equation. So we've got an example right here. But it says that, note, this is not a function. It does not pass the vertical line test. And there's another note. Consider a function defined by a polynomial in x. If the function has only even exponents, it will always be an even function. Similarly, if only odd exponents appear on x, then it will be an odd function. So these are some examples that you want to look at. I am going to do some examples from the homework. That way, it's just easier to see that way. Lesson 3, it says apply transformations to graphs of various functions. So we have a summary of our graphing techniques. This is important information. It says in the descriptions that follow, assume that a is greater than 0, h is greater than 0, and k is greater than 0. And then remember that y equals f of x. So it says that the graph of y equals f of x plus k, that it is translated k units up. So I'm going to do this, and then I'm going to say translated k units up. Then we've got the graph y equals f of x minus k, and then it goes opposite, so it goes down. The graph of y equals f of x plus h, and it says that it is translated h units to the left. Let me highlight translated. And then for f of x minus h, it is translated h units to the right. So don't get these two mixed up. I know that whenever we are working with k, positive k goes up, negative k goes down. But in this case, positive h is going to the left and negative h is going to the right. Okay? For the graph of y equals a times f of x, it is a vertical stretching of the graph if a is greater than 1. It is a vertical shrinking if a is in between 0 and 1. Okay, the graph of f of a times x is a horizontal stretching, and it says that if a is between 0 and 1, it is a horizontal shrinking if a is greater than 1. So whenever it says 0 is less than a is less than 1, and it has a in between 0 and 1, that means that we are going to be looking at a fraction, or like an irrational number. The graph of y equals negative f of x, it is reflected across the x-axis. And then f of negative x is reflected across the y-axis. So this is a lot of information. This stuff right here is very, very important. I'll put stars around all of this stuff. This is what you will need whenever you are graphing. So please, please, please write down this information. Have it handy on you. All right, so we have some examples. They give us our parent graph, which in this case we're looking at y equals x squared. And so our parent graph we have on the origin. But we have some stuff that we're doing to it. So the first one, we have our black graph, and it says that y equals x squared plus 3. So if we look, whenever we have a plus and then a constant, we're looking at number 1. So it says that it's translated k units up. So in this case, it's going up 3 points. So you would just basically grab your graph and move it up 1, 2, 3 points. The green graph has -3, so it's translated 3 units down, and so we would move it 3 points down. Okay, so these are working with numbers 3 and 4 above, and this is whenever you have f of x plus h or minus h, so in the parentheses. So we start off with y equals x squared, and that's the red graph. And we have our point on the origin. And then we have, in the black graph, we have x plus 3, and that's in parentheses, and that is squared. So remember, anytime that we have a positive h, it is going to go to the left. And then a negative h is going to go to the right. So this is the graph with the plus 3, and then we have minus 3. So we move it over 3 points from our origin. The next one, we are looking at the shrinking and extension or stretching of our graphs. So our parent graph that we're looking at, the red one, is going to be that y equals the absolute value of x. So that's going to be our red graph right here. Let's look at our rules real quick. So it says that we have a times f of x, and that is a vertical stretching. So if a is greater than 1. But if it is a fraction, then it is going to be shrinking our graph. And then we have f of a times x, and that is a horizontal stretching. And that one is if a is a fraction, and then it's a shrinking if a is greater than 1. So let's look at what they're giving us. In this case, we're looking at 1/2 times the absolute value of x. So in this case, a is going to be between 0 and 1. So if we look at our rules, we are looking at this one right here. And since a is between 0 and 1, we're looking at a vertical shrinking. Okay, so if you look at the black graph, that means that our graph, our original graph, is going to be shrinking down. So this is what it would look like, this black dotted line. And then for 2 times the absolute value, a is greater than or equal to 1, so the graph stretches vertically. So that's going to be our blue graph. The next one is the horizontal shrinking and stretching. So we have inside of the parentheses, and remember this one is opposite of the one we just looked at. So whenever a is in between 0 and 1, then it's going to stretch, and if it is greater than 1, we will shrink it. So look at those examples. The last ones is going to be the reflections. So we have our original, our parent graph, y equals the square root of x, and then if we have a square root of negative x, we are going to translate across the y-axis, so it's going to reflect over our vertical line. If it is negative square root of x, you're going to translate across the x-axis. That is going to be our blue graph down here. And then you can also have multiple translations. So you just have to look and do them piece by piece. So check out these examples. I'm going to look at our homework. Number 1 says, which one is the graph of f of x equals x squared? So they give us the graph, and we're not actually graphing it, but we are choosing from our multiple choice. This one we just went over in the notes. The f of x equals x squared is our parabola. So if you look over here, this is what it would look like. F of x equals x squared. So let's look for that particular graph here. Some of these you are going to have to make bigger. So I can see now that it's going to be C. It's our parabola. It's on the origin, and it has symmetry over the y-axis. So that is our answer for this one. There is going to be a question like that on your test. Most of these, oh, I'm not done. Most of these that I am going over are going to be the questions from your test. All right, so what is our domain? So I did give all of these, the domain, the range, everything. If you look in your notes, I think it might be on this one. So our domain is going to be negative infinity to infinity. That's going to be our x. The range is from 0 to infinity. So let me go ahead and type this in. Negative infinity to infinity. Enter. All right, so that one I guess only asks the domain. It doesn't ask about the range. Number 2, you will have a question like this one, and we're looking at for equals x cubed. So this is going to be our graph for this one. So let me make this bigger so we can see. Looks like we are looking at graph F. That's the only one that matches. And then our range is negative infinity to infinity. If you can't tell that this is going on and on and on in the y's, then use your notes. So I've got negative infinity to infinity, and I'm actually going to copy this. That way I can just paste it. All right. Okay, number 4, we are looking at this graph. It says, which graph is the graph of f of x equals, and this is the cube root of x. And it says, is there any interval over which the function is decreasing? So we do look at this one in our notes. It's the cube root function, and so our parent graph is going over the origin. So let me make this bigger, and it looks like we have letter A. Okay, and then it tells us the domain and the range, and it says, is there any interval over which the function is decreasing? And remember, whenever you do look at these whenever you do look at these graphs, think of it like you're reading a book. You read a book from left to right. So if we were to look at this graph from left to right, we would be coming up from the bottom, and we would go up to our origin, and then we would continue to go up. So it is not decreasing, it is only increasing. All right, I'm not going to do number 5. I'm not going to do number 6, but I will do number 7. Number 7 says, determine the intervals of the domain over which function is continuous. So you're looking at our domain. Remember, our domain is our x. The range is the y. So it says we want to see if the function is continuous or not continuous. So this does look like our graph that we have in our notes, but the graph that we have in our notes is coming from 0 and on. this graph is at 2, so starts at the point 0, 2, and then goes on. So it is continuous, and don't let this confuse you. They are asking about the domain, so we're still looking at our x. So in this case, x is 0, so we are not going to move this. Yes, this has made a translation up, but that is working with our range. Our domain is still starting at 0 and going on into infinity. So 0, infinity. So that is for our domain. And then I'm not going to do number 8. So that is for that is for 3.1. 3.2 I'm going to look at next. Alright, so our homework for 3.2, it does not go over the translations that we talked about. That is going to be on 3.3. It does talk about the even and odd functions. So the questions that we are going to look at is number 4. So we're only going to look at number 4 because this is the only one that is similar to the test question that you will get. So it says decide whether f is even, odd, or neither. And so we have that f of x equals x to the 4th So it says that f of x equals x to the 4th minus 3x squared plus 6. So this one is going to be even because we have x to the 4th, which is even, and then x squared, which is also even. All right, and then let me look at 3.3. All right, so 3.3 is a little bit longer than the other ones, but it does have a lot of the questions that we're going to be looking at on the test. So it has different graphs that we're going to be, or different functions that we're going to be graphing. So it has different functions that we are going to be graphing, and you do have a couple of these on your test. So you're going to be given a function, and then you are going to need to graph it. So these are very good practice. The one that I'm going to look at first is number 2. So let me go over to 3.3, and I'm going to keep this up because this is so very important. It tells us everything that we need to do. So it says graph the following function. We have f of x equals 3/4 times the absolute value of x. So we have an a that is in front of our function. And if we look at our roles, if a is in between 0 and 1, so if a is a fraction, which it is, then we're looking at number 5. Then we are going to do a vertical shrinking. Okay, so we have f of x equals 3/4 times the absolute value of x. What you want to do on these, so this is for check for understanding 3.3, and we're on number 2. We have that f of x equals 3/4 times the absolute value of x. So what I'm going to do is I'm going to create a table. And if I set x equal to 1, so f of 1 equals 3/4 times the absolute value of 1. So I'm going to change x to 1. So our absolute value of 1 is just going to be 1. So our y would be 3/4. Okay, let's look at the number 4 for x. Since we've got 3/4, let's look at 4. So f of 4 equals 3/4 times the absolute value of 4. So what is an absolute value? An absolute value of a number is the non-negative value of that number. So it's always going to be positive. So if we were to have -4, it would still equal 4. In this case, the absolute value of 4 is just going to be 4. So we've got 3/4 times 4. These cancel out and we get that y equals 3. So we have a point that we can use to graph our function. So I'm going to click on here and let me zoom in just a little bit on this so everybody can see. So we know that our absolute value is going to be this V shape. So I'm going to click here. And our graph is not being translated up or down or to the left or right. So it is still starting in the middle on our origin. So you're going to click there. And then we can graph our other points. So we need 4, 3. They don't tell you at the top like our other graphs, or there might be something wrong with my computer. But I can see the dotted lines, and x equals 4, y equals 3. So I'm pretty sure that that's going there. Okay, let me save this. All right, let's check our answer. Great job. So on a lot of these, it is best to use these tables. That way you can find a point and use it for your graph. All right. So that one is kind of similar. Okay, so number 4. It says graph the following function, f of x equals negative square root of negative 36x. So let's look at our rules. We have, we're looking at 7 and 8 for sure because we have negative f of x and then f of negative x. So since we have those two negatives, we are going to do a reflection across the x-axis and across the y-axis. So if we look at our graph down here, and we were to, this is our parent graph. The red one is our parent graph. So this is what we are going to be changing. If we were to reflect it across the x and then also across the y, it's going to be somewhere over here in this quadrant. So we know that it's going to be either C or B. So the other piece of information that we have is the 36x. So let me scroll back up to our rules. So we are going to be looking at number 6. It says the graph of y equals f of a times x is a horizontal stretching or a shrinking. So in this case, a is greater than 1, so it's going to be a horizontal shrinking of our graph. Alright, so before I graph this, I am going to make a table so we can look at some of these points. Now, if you have a graphing calculator, these can be very, very easy for you to do. You are allowed to use the calculator. So first I'm going to build a table and then I'm going to look at our calculator. So we have x and y. And let's look at where x equals 1. So for f of 1, it equals, let me scoot this over, negative square root of negative 36 times 1. Actually, let me do a negative 1 so I can get rid of that. So f of 1 equals negative square root of 36. So our square root of 36 is 6, but we have our negative that we have to bring down. So where x equals negative 1, then y equals negative 6. Okay. I'm sorry, let me do negative. So let's look at our graphs. So like I said, we know that that this has gotten translated over the x and y axis. So it's going to be one of these two graphs for B and C. So let's look at B. We need one of the points to be on -1, 6, which would be somewhere down here. So I don't think it's B. Let's look at C. -1, 1, 2, 3, 4, 5, 6. Are these 2's maybe? So 1 and then 2, 4, and 6. So yeah, it is C. So we know that it's one of these two graphs. And we know that our point needs to be -1 and then -6. So it's going to be somewhere down here, not over here. So it's going to be C. And if you do need that extra help, just use your calculator and graph it. So we've got negative, and then we've got second square root, and then -36x graph, and we have our graph right here. Okay, number 5, graph the following function. So this one is a little bit easier because it is a translation. So we have x squared plus 5. So it is going to be translated k units up. So in this case, we're going to go up 5 points. And so we are using x squared. So if we look at x squared, it's going to be this parabola right here. So I'm going to click to enlarge, and we've got our parabola. And so it's not going to start at 0, 0, where it's going to be translated 5 units up. So it's going to start at 0.05. Okay, so there is not a stretch. There is a vertical shift of 5. I'm not sure why it didn't do that when I chose the point. So it is a vertical shift of 5. Okay, save. All right. Number 6. Okay, so we have our function, and then we have x minus 7 squared. So let's go back up to our roles, and we're looking at number 3. So we have number 4, x minus h. All right, and so we still have our parabola that we're looking at. We just have a translation that we are going to be going to the right. In this case, we're going to be going right 7 points. So we still have our parabola. We're not starting at 0.00. We're starting at 0.70. So we don't have a stretch. We do have a horizontal shift of 7, and we do not have a reflection. Hit tab so that your graph moves over. Okay, we can exit out of that, and then we'll save it. And that is our graph. All right. This is kind of similar to the one that we looked at. Let's look at number 8. All right, so we have another square root, but this time we have x plus 2 inside of our square root. So we are going to be doing a horizontal translation. Since we have a positive 2, it is going to be going to the left. And so x plus 2, so it's going to be going to the left 2 points. So let's look at these graphs. Our parent graph, remember, comes from our origin and goes up. This is not a negative, so we're not going to be doing any type of reflections. We're just going to be moving our graph to the left. So this one looks like it's going up. This one is going down. C looks like it's the one that we want because it is going to the left. Great. Number 10. Let's look at this one. It says f of x equals 3/5 times, and then we've got x minus 4 squared. So we do have a parabola, but we have a couple other things that we're looking at. We have our a in front of our function, and a is a fraction, so it is in between 0 and 1. So we are looking at number 5. Since a is between 0 and 1, we're going to have a vertical shrink. And we're also going to have a translation. We have x minus 4. So it's going to go to the right 4 units. So we have a vertical shrink and a horizontal translation that we need to look at. So we're going to start with our parent graph. I'm just going to go ahead and click since this thing pops up. So remember, we have a vertical shrink. So I'm going to change this to 3/5. And then we have we have a horizontal translation. So it's going to shift horizontally to the right by 3. I'm sorry, not 3, 4. Okay. Save. All right, great. These, I'm not going to look at these. But that is all for Module 3. All right, so let's look at Module 4. Module 4, we're going to be looking at different operations with functions. So let's look at our notes. I'm going to go over our notes first, and then I'll look at the homework. Module 4 and Module 3 are combined in the assessment. So we have a couple rules. We have what each of these are going to do. So if we have f plus g of x, then we're going to find f of x and add it to g of x. Similarly, if we have f minus g, we're going to subtract f of x minus g of x. If we multiply, we're going to multiply those two, and if we divide, we are going to divide. And remember, our denominator cannot equal 0. So there are some examples of these. I'm not going to go over these specific examples. If you want to look at them, you can look at the notes. I am going to go over some of the homework questions. So that is 4.1. 4.2 says to use graphs or tables to find the sum, difference, product, or quotient of two functions. So look at these examples that they have, and I am going to look at I am going to do some of the homework questions with you. And then 4.3, composition of functions and domain. It says if f and g are functions, then the composite function or composition of f is defined by g. If f and g are functions, then the composition of f and g is defined by this. So we have f of g of x equals f of g of x. So basically we have to calculate g of x first, and then we'll find f of x. Okay, there are some examples that you can look at. Like I said, I'm going to be doing the homework questions. All right, so 4.1 homework. They give us f of x, g of x, and then we're going to be performing some of these operations. So f plus g. Let me look at number 3. 1 and 2 are pretty simple, but I'm going to do number 3. So this is the check for understanding 4.1, and this is number 3. And so we have that f of x equals x squared minus 12, and then g of x equals 16 minus x. And then we have f of g and then 11. So first, before I input our 11, remember what our rules tell us to do. It says that if we have f divided by g, we can put f of x over g of x. So I'm going to do f of x over g of x. So before I input our 11, I'm going to leave this as x. So that means we have x squared minus 12 divided by 16 minus x. Now, if we input x for 11 for x, then we've got 11 squared minus 12 divided by 16 minus 11. I'm going to put all this into our calculator. I've got 11 squared minus 12, and I'm going to put this all in parentheses. And then I'm going to do divided by 16, 16 minus 11. Enter. And we get 21.8. All right, great. Number 4. So we have, let me do a different color. We have that f of x equals 5x plus 4. G of x equals 4x minus 7. And we want to find f plus g of x. So we're going to find everything. We're going to do f plus g of x, f minus g, times, and then divide. So remember our rules. We just basically are breaking them up. So this one is going to be f of x plus g of x. So we've got 5x plus 4. This is our f of x plus 4x minus 7. And we can combine our like terms. So 5x and 4x is going to be 9x. And then we've got 4 and negative 7 gives us negative 3. So I've got 9x minus 3. All right, let's look at f minus g of x. And that's just going to be f of x minus g of x. So we've got 5x plus 4 minus 4x minus 7. Now, remember, we have our minus right in the middle. So that means that that operation is going to be for both of these terms. So if we were to like use it as like distributing it, we would have 5x plus 4, and then we have minus 4x. And then if we have a double negative, we have negative 7, and then the double negative, that becomes positive. So 5x minus 4x gives us 1x. And then we've got 4 and 7 is a positive 11. So I've got x plus 11. All right, the next one we're going to multiply. F times g of x equals f of x times g of x. All right, so we've got 5x plus 4 times 4x minus 7. So we're going to use our FOIL method. First, outside, inside, and last. First is going to be 5x times 4x gives us 20x squared. Our outside is 5x times negative 7 gives us negative 35x. Inside, 4 times 4x gives us a positive 16x. And then last, 4 times negative 7 is negative 28. We can combine our like terms. 20x squared, and then we've got negative 35 and positive 16. We are going to get a negative 19. So negative 19x. And then minus 28. Okay, so I've got 20x squared. Make sure you get out of that box. Minus 19x minus 28. Okay, excellent. And then the last one, we're going to divide. So f over g of x equals f of x divided by g of x. So we've got 5x plus 4 divided by 4x minus 7. So we are going to leave our answer like this. So I need a fraction. We've got 5x plus 4 divided by 4x minus 7. Great. So now it's going to ask us for our domain of each of these, starting with f plus g. So f plus g, we have 9x minus 3. So this is just going to be a line. It is going to be our negative infinity to infinity. And then same thing for x plus 11. And then for c, we're looking at the same thing. I'm sorry, it's not the same thing, but it is negative infinity to infinity. Because remember, we're looking at our domain. The domain of f of g, so this one is not going to be negative infinity to infinity, only because our denominator cannot equal 0. So since our denominator cannot equal 0, 4x minus 7 cannot equal 0. So that means that 4x cannot equal 7. That means x cannot equal 7 over 4. So our domain is going to be everything except for 7/4. So 7/4, I'm just going to add it to this. And we are going to union, and then this, and then 7/4, comma, infinity. All right. So this one is kind of long. That one is on the test. All right, and I'm not going to look at this one. All right, for 4.2, this one is super short. Let's look at number 2. It says to use the graph to evaluate each expression. So now we're going to be doing what we just did in that previous problem, but now we have a value for x. So let me get a green. All right, so on a all right, so use the graph to evaluate each expression. So they give us what y equals, and then they give us what g equals. So on part A, now we don't necessarily have to find their graph. This is number, okay, hang on. This is check for understanding 4.2, number 2. So A, we are looking for f plus g, and then x is -3. So remember our rule, this would be f of 3 plus, g of 3. So let's look at our graph. The blue equation is for f of x, and then the dotted pink one is g of x. So where x equals 3, we want to, look, 1, 2, 3, 4, 5, 6. So x equals 3, 1, 2, 3, and I'm going to go up. So y equals 1, 2, 3, 4. So y equals 4 here. And then let's look at 3 at g of x, and that is going to be y equals -1. So 4 minus 1 is 3. Oh, hang on, this is -3. Okay. All right, see how easy it is to make these mistakes. So I put +3. We are looking where x is -3. So let's look at this again. So I'm looking at where x equals -3. So 1, 2, -3. Y is -2. And then on g of x, I'm going to go to x equals -3, 1, 2, 3. And then I'm going to go up 1, 2, 3, 4, 5. So y is 5. So -2 plus 5, or 5 minus 2 is 3. So really the same answer. Okay. Part 2, f minus g. Okay, and then we're looking at -4. So f minus g, and then -4. That's going to be f of 4 minus g of 4. -4. I did the same thing. So negative and negative. Okay, so let's go to where x equals -4. So 1, 2, 3, 4. Our f of x is 1, 2, 3. So this is -3. And then for our g of x, 1, 2, 3, 4. And it goes up to 1, 2, 3, 4, 5, 6. And this is +6. So -3 minus 6 gives us -9. Okay, on part C, f times g in this one we're looking at -2. Okay, so that's going to be f of -2 times g of -2. All right, let's look at our graph. Where x equals -2, 1, 2, y is -1. And then for g, we've got 1, 2, and then y is 1, 2, 3, 4. All right, so -1 times 4 is -4. And then the last one is going to be f divided by g. So I've got d f over g, and then we're looking at for the point 0. So that's going to be f of 0 divided by g of 0. And remember, this cannot equal 0. So let's look at our graph. So for 0, where x equals 0, y for our f of x equals 1. Okay, so we've got 1 divided by And then for our g of x, x equals 0, then y equals 2. So we go up 1, 2. Okay, so this one works out. This would be 1 divided by 2. All right. And then this one is on the test, and it's similar to the one that we just did, but I'm not going to go over that one. All right, for 4.3, I'm going to look at number 1. So check for understanding. 4.3, and this is number 1. So it says that f of x equals negative 3x minus 1. H of x equals negative x plus 5. And we want to find f of h where x equals negative 4. So remember, we have to find h of x first before we can find f of x. So that's what this equals. So h of negative 4 equals negative 4 plus 5. So this becomes positive, and we get that this equals 9. Now we can input 9 into our f of x. So f of 9 equals negative 3 times 9 minus 1. So 3 times 9 is 27. We have negative 27 minus 1 equals negative 28. All right. And then this is the other one that's on the test. So there's 2 test questions from this section, and it is very similar. It's just backwards. So number 2, f of x equals negative 2x minus 1. And then h of x equals negative x plus 3. And we want to find h of f where x equals 5. So this is going to be h of f of x. In this case, x equals 5. So we are going to find f of 5 first. So that is going to equal negative 2 times 5 minus 1. So I've got negative 10 minus 1 is negative 11. I'm going to input this into our h of x. So h of negative 11 equals negative times negative 11 plus 3. So this becomes positive, and this equals 14. Positive 14. All right, and that is all from this homework.